So let's take, that is, what do you call it? The next one. Here. Reaction, I have my, is it 3 or 4? Something like that. So I have my CH3, CH2, MgCl with aldehyde. Plus the aldehyde here is H hydrogen. That is HCH0. This is it. That is methanol. So, in the presence of dry ether, I'm going to get, very important, I will show us the mechanism. How do we get that? But for the now, let's see what we do. We have CH3, CH2. This is coming here. I have my carbon. It's going to give me one O here. Okay. And MgCl. MgCl. These two hydrogens are here. Now this will react with water. Hydrogen hydroxide. When that happens, this will come in here and the other one will go. So I now have CH3, CH2, CH2, which is this, OH plus MgOHCl. Now let me show you the mechanism. How do we get here? If we do not know the mechanism of action, everything here is bullshit. So we must also, or all the time, try to follow how the principles operate and how do we get there. So let me bring out a shorter formula so we can show the mechanism. We're dealing with aldehyde. So from here, we're able to get a primary alcohol. When we react with methanol, we get a primary alcohol. So when we react with ethanol, obviously we get a secondary alcohol and so on and so forth. But before we go into the ethanol to get our secondary alcohol, let us see the mechanism of that reaction so we're not going to be confused. Mechanism. I don't know if I should claim this. This is the mechanism. I have my CH3, CH2. Okay. Now, from here and here, the air is negative. And MgCl is my positive here. Plus, here is hydrogen, CO. Remember, I will show you that. How is that? And here I have hydrogen. Let me explain this first. This is what I have. HC double bond O hydrogen. Remember, I moved this bond to here so that it becomes what? Negatively charged, so that I can attract electrons. So if I turn it this way, I want to turn it to face this way. I will have hydrogen up. Remember, C down here, the O is going this way. This is the O or the 0 here, which is negative, and here is my hydrogen. So it's either I leave it this way or this way. That is what I have created. Alright? So in this sense, this is what happens. So if that is true, now this is coming here. I'm bringing this. So when that happens, remember this carbon. So thank you there. This carbon is now 3. Means it's deficient. It's electron deficient. Becomes positively charged. So if that happens, you know that this negative will come here to the positive, and this positive will come to the negative. So let me take this one out and replace those ones. So having done that, remember, positive to negative, negative to positive. Now, this is my carbon, the positive. So this is carbon. I have my hydrogen here. Let me put the other one here. So this one is negative coming in here. So let me put that one that is coming in down here. So this is CH2, CH3. We are good. So that one has taken place. Then this 0 here is still there, and this positive, remember 0 is negative, this positive is coming in, becomes MgCl. This is the same thing as this. I just have to turn it in a way so I can accommodate this space. Now, I want to react this with water. That water you see. So plus hydrogen, OH. We know hydrogen group is negatively charged, this is positive. Here is positive, here is negative. So the positive will come here. When the positive comes here, let me now turn this guy this way. I will now have my CH3, CH2. Here is CH2. The O0, which is negative, plus this, that is OH, which is this. What is left now, the positive will come to this other negative. So this is my Mg, OH, and Cl. So this is the mechanism of that action there, which you see. I just have to show so I will understand. I will not going to be lost. So this is reaction with methanol, which gives us propanol. And that is a primary alcohol. Primary alcohol, we say the definition for a primary alcohol, the carbon carrying the OH group is attached to one other carbon and two hydrogen. So that's the definition for, it's a simple definition for primary alcohol. I don't know if I have to explain that further. So let me take this out, we can proceed. So the second one with ethanol, too. I've forgotten the number. With ethanol, I have my CH3ClMg plus CH3 C double bond O hydrogen. This will give me, this will come in here, while this would match with this. So dry ether, I will now have my CH3 here, carbon O negative, hydrogen is up. I have to slide it, don't forget. And my CH3 there is here, CH3 is here. And here I have MgCl. Now, in the presence of water, I will have my CH3, C, hydrogen up, CH3 down, OH plus MgOHCl. This is what we get now. Now this is a secondary alcohol. This secondary alcohol. Why is this secondary alcohol? We say the carbon carrying the OH group is attached to two carbon atoms and one hydrogen. The other one, the carbon carrying the OH group, is attached to one carbon atom and two hydrogen. Primary alcohol, secondary alcohol, two carbon and one hydrogen. While tertiary will be three carbon and no hydrogen. So this is it. Let us get a tertiary alcohol and probably a carboxylic group. Then we move on to something else, into full synthesis. Haven't done this old stuff. We know that when we get into the synthesis, we're not going to be lost. We understand the principles on how to maneuver what we want, and by virtue of that status quo, we'll be able to proceed further without much problems. The tertiary alcohol, we react that with propanol. Okay, whatever the number is. I have with propanol. I have my CH3 MgCl, which is my Grignard reagent, reacting with CH3 C double bond O CH3. This is my propanol. Now, simple explanation. This will move down here, becomes negatively charged here becomes positive. It will be one thing, to this negative will come in here, and this positive will come to the oxygen side. So take note. If I have this with dry ether, I want to replace this in this manner. I have my CH3, CO negative, remember? And this other CH3 is here. The positive sign that is meant to be here will be replaced by this. So I have my CH3 here, and now I have OMgCl. This is what I get. And in the presence of water, I can easily now have, okay, here, CH3 carbon, CH3, CH3, OH plus MgOHCl. This is a tertiary alcohol where the carbon carrying the OH group is attached to 3 carbon atoms and no hydrogen. So this is how we can get our tertiary alcohol through the use of what? Grignard reagent. Now, how do we get the carboxylic group? So you begin to see that through the aid of Grignard reagent, this particular reagent, we'll be able to get our alcohols, primary, secondary, tertiary. We are even ending on getting our carboxylic groups. So by virtue of that, if I were to use a compound that has to do with, let's say, propanoic acid, and I need it to synthesize, and I do not know how else to start to bring in the, the propanoic acid, but I know my Grignard reagent very well. I can use these principles and get the what? Propanoic acid, then I proceed to get whatever I'm dealing with. So it becomes a very key or a cardinal what? Procedure, which can never be ignored. Without it, makes synthesis difficult. So we are looking at the areas in which we can double into to simplify synthesis. So when we get into synthesis in full, you see how everything will be unfolding without trouble. So let's deal with the other one, then we'll go into synthesis itself now. Grignard reagent, CH3ClMg with carbon 4 oxide will give us what we want. Alright, so I will just show something before I proceed. This carbon 4 oxide, if I move this carbon here, this bond here, I have O negative here. And here I have my O. Here become positively charged, which will be wanting that this will come in. Okay, no, this negative and this positive, this will come in here. And if this comes in here, this becomes CH3. And this one goes in here, it becomes OMgCl. If I put in water, hydrogen will replace here. Hydrogen will replace here if I put in water. And I have 1, 2. This is ethanoic acid. So you should understand through the mechanism which I've shown us earlier how those things can be done. But now let me move on in case so I wouldn't ask much question. How did he get that? Now we move. So this will give me my CH3 from here. The carbon is here. Let me put my double bond here. OMgCl. That's what I get there. Carbon is balanced, everything is okay. In the presence of water, the hydrogen hydroxide, I have my CH3, C double bond O, OH, plus MgOHCl. This other OH, that is what comes in here. So this is ethanoic acid. So this is my ethanoic acid. So Grignard reagent has been a very important factor in our course of synthesis. Let's take one example first in synthesis. So let's call it synthesis in action. Synthesis in action. Let's take I don't want to start with paracetamol. Let's take benzocaine. This is the structure of benzocaine. Now, the question is, how can we synthesize this? Probably starting from benzene. Okay, I will write it up there so that we can move on. Let me put it here. We are going to be referring to it as we go on. COOCH3. This is my NH2, a minor group. Okay, now synthesis of benzocaine. Alright, I'll start from benzene. So this is my benzene. I will first go with methylation, yes, which is CH3Cl. I have my aluminum trichloride here. This will give me this. Give me CH3. This is my first guy. And this I have gotten. I have to bring in an amino group. And I can't get amino group directly, so I have to bring a nitro group first, which I will be converting to amino. So I'll have to move further. Why am I bringing nitro group? Because I know that this guy is autopara directed. So now I will bring in my HNO3. You see the reason why I have to start from here. HNO3, H2SO4, and this will give me CH3 NO2. I move further within the presence of HCl. I'll get this CH3 NH2. I'll move further. I will oxidize this KMNO4. If that undergoes oxidation, it changes the methyl group into a carboxylic group. So I now have this into a carboxylic group. Because of that reaction, the KMNO4 there, that's converted it NH2. Now, what is left? I need to introduce a CH3, and that is an ether. So the only way I can do that, I have to esterify this, reacting with methanol, because CH3. I will, CH3 OH in the presence of concentrated acid, H2SO4. This will give me this. It changes this to COOCH3, and here I have my NH2. This is my benzocaine. So it is important, if we do not know our electrophilic substitution reaction, and also know which of them is meta-directing or para-directing, or and so on and so forth, or ortho, definitely we can't start, we can't even think of it. So the more reason why I have to start with what? Electrophilic substitution reaction. I will move on. And through the course of getting my benzene diazonium chloride, I was also informed that when I have to react this nitro group in the presence of this, it converts it to an amino group. And now we know that when we reduce this, oxidize this, it gives us a carboxylic group. Here we are, and we esterify it to get that. We move on. Let's take another example to synthesize. We're dealing with synthesis here. Okay, let's move. Okay, saccharin. Let's deal with saccharin. This is C double bond O. This is my sulfur group. And this is nitro. So this is the structure of saccharin. How can we synthesize this? It is very, 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 very important. So let me write it out so that we'll be looking into it as we move on to know what you're dealing with. But it is important you know the structures without you seeing them. Let's maybe say exams or something. I can easily, or somebody can easily ask you, how do you synthesize saccharin? You can't synthesize what you don't know, the structure of what you don't know. So if the person is being very good, they decide to give you the structure. And when you have the structure, you can start whatever you want with it. You can begin to dance around it. You think of your benzene, okay, I've seen a benzene ring here. Now if I have the benzene ring here, this is a carboxylic group. I can easily get this carboxylic group. How can I get the carboxylic group? I'll go through methyl, use KMNO4 to get the carboxylic group. This is a sulfur group. I can easily bring in sulfonic acid in the course of that. So if I can put in my sulfonic acid, then definitely I can now get something like this. And there is an amine group here, which means I have to react with maybe ammonia or something. And there I will be. So let's try that and see what we do. Okay, now I have my benzene. Yes, let's begin here. It's always, or not always, most often the starting point. If I undergo methylation, yes, CH3Cl, AlCl3, I will have this. Now, because of this positioning here, I will take this to be my position 1, CH3. Now, if that is true, methyl group is auto-para-directing. This guy is auto-para-directing. If this is not my position 1, it means here is my auto, these two. These two here are my meta, and this is my para. Don't forget that. This thing can be twisting sometimes. Remember I told us earlier on, any position you take as your position 1, then from there you can define your auto para from there. Let's see if I were having this, if this is occupied. Okay, let me just use CH3, sorry. This is auto. If I have this, this is occupied. Here it becomes my auto. These two become my meta. These two my meta, and this is para. And this become my para, like this, like this. Alright? And so on. If I take this as my position 1, these two auto, meta, para, the same. So don't forget that this now being my position 1, these two now become auto. This other one meta, and this is para. I can slant it anyhow I want. So let us go on. Okay, if I react this with chloro SO2 OH sulfonic group. Yeah, chlorosulfonic group. Let's look at that again. Yes. So that will go to my auto para positions. I will put them down here. So this will be here. This is my CH3. And this is not auto. This will come in. Cl, here, SO2. 1, 2, 3, 4. Cl2. That will be here. Then the other guy, remember since it's auto-para, it means I will have two structures. But because of synthesis, I will move on. If this is my CH3, this becomes the para position, which gives me my ClSO2 here. So, but I'm going to make use of one so that I can proceed with what I'm dealing with. So if I have that, I can move on. So let me take the other one. I'll continue with this one. Okay. The next thing is I want to bring my carboxylic group. I want to change this. So I can easily put this KNNO4 as the oxidative element there. I will now have this. I will now have COOH and ClSO2 here. So there we go. Now, if I react this with ammonia, NH3, chlorine will take one of this out. There is 2 here, it's chloro. Okay. Chlorine will take one of the hydrogen out, the amino group will be left. So I will now have this. Now I have COOH and I have SO2NH2. Now, if I take out a molecule of water here, H2O out, I'll be left with this. Hydrogen will complete here. Yeah. So then we go minus H2O, and I will have this. This is my sulfur. SO2 has been taken care of. This is my carbon. Oh yeah. This is my nitro and hydrogen. Okay, with this I'm good. This is my H2O out. This O here, this is it. This other O2 is here. Okay, good. We are good. That's saccharine. So by virtue of that, we have been able to synthesize it. But you don't forget, our ability to do that is also embedded in that act of we manipulating our benzene with the various electrophilic substitution reactions, and so on we move. So let's look into the synthesis of is it? Yeah? Yeah, that is paracetamol, okay? That aminophenol. Para-acetyl aminophenol. So we can take that. Now, we go. So, synthesis of paracetamol. This is my paracetamol, OH, and hydrogen, double bond CH3. Remember, CH3 and nothing here, they are all the same thing. This is para-acetyl aminophenol. That is the, what do you call it, chemical name for it, the IUPAC name for it. So this is paracetamol. Now, let's synthesize paracetamol. We are going to get our phenol. And remember, our process of getting phenol is long, but we're going to manage. I think so, we're going to manage. So let's take that from, we want to go to phenol. We start from our benzene ring. So I'm going to economize the bond this time around. So I have my HNO3 here in the presence of H2SO4. I have my amino group. No, the nitro group. I have the nitro group. This is it. I move the presence of plain HCl. I have aniline. Yes, right. I have aniline, NH2. I move further to nitrous. In the presence of HCl, permit me to clean this other guy, please. We don't need him now. Then, when I do this, this will turn into benzene diazonium salt. I have my N2Cl. This is what I get. And when I proceed further in the presence of water, I get phenol. It's a long way. I get phenol. So now we move. If I have phenol, I want to put an amino group. I must go through almost the same principles here to here. So from here, my phenolic group will come this way. I have my phenol. Will react with HNO3, the presence of H2SO4. I will have base. I'll have nitrophenol. Use my thing, the presence of HCl. And I have aminophenol. Ethanoic chloride, CH3 C double bond OCl comes in. This is my phenol. This is my nitro. When this comes in here, remember nitro is H2. The other hydrogen will take the HCl out. Then we bond with this. Carbon, double bond O. I have my CH3 here. This is paracetamol. So this is its synthesis. We have to get used to that. And that's that. So let's move further. I don't know. Maybe we should start retrosynthesis. Maybe I should just, let's take one example of retrosynthesis. What's retrosynthesis? Is the dismantling of the target molecule back to its initial reagent. Like I have this up to this. I can break this down back to this. That is retrosynthesis. We have a lot of them. I don't know, or probably we can capture in the next class, but for the now, let's look into the catabene ethyl ether. Okay, let me bring that out. The catabene ethyl ether. This is catabene ethyl ether. We are going to take this one as assignment. Now, how do you get your catabene ether synthesis and retrosynthesis of this compound? It's your assignment. So you can do this, send it to the platform. I'll check it out and confirm if there is a need for me to solve it, But I'm going to give us the basic principles, what we should need. First, you have your benzene ring. Alright? So in that benzene ring, you have a methyl group here. The methyl group is autopara-directing. So the next thing that comes here is nitro. You react it with HNO3, H2SO4. You have the nitro group, which in the presence of thin HCl, you change it to amino. And you still react that with ethanoic chloride. No, ethyl. Yes. Chloroethyl will now give you this. With chloroethyl, you get this. Now, if you've gotten this as your chloroethyl, this is what you are having now. With CH3 here, you can now use your oxidation reaction. KMNO4 changes the CH3 to COOH. The COOH will be esterified with ethanol. You get this. So virtually, I have given you everything. So now again, if we want to retrosynthesize, which means we should bring it back to the initial, I can easily cut from here. I will be left with this. Come here, cut it off. I will be left with this. When we get to retrosynthesis, fully, I will explain how those things work. But for the now, this is where we should stop for the day. If you haven't subscribed, you have to do that so that you're not going to miss too much, and you'll be obviously welcome. If this is your first time, thumbs up to you. I always press the like button when you subscribe. Have a nice day. Thank you.